Hello everyone, let us discuss the water chapter first. Let us continue the water chapter first, and then at the end I'll discuss the 5 distinguished chemicals that I gave last day. So previously we were talking about the presence of water in a salt, water crystallization, anhydrous and crystallines, which are hydrated crystalline, anhydrous crystalline, and so on. So today we will be defining certain terms. First of all is efflorescence. Now efflorescence is a property or a phenomena where there are continuous giving out of the water of crystallization, or on heating the water of crystallization of a particular salt continuously goes out or escapes out, and the salt from crystalline to amorphous, it becomes from crystalline to amorphous substance, and also sometimes color gets changed. So efflorescent salts are those salts which are having this property of giving out the water molecules and changing its crystalline form to amorphous form, and sometimes changing its color as well. Basic example is blue vitriol. If we heat blue vitriol, the water molecules escape out, it turns to white amorphous powder from the blue crystalline solid. So from here you can get give reason based question, and basically this year also in 9th board exam we got some give reason based question from this part. So this is one example: green vitriol, FeSO4.7H2. Initially it is green in color. If you take out the water molecule, it will turn to amorphous powder, and the color also will change, and it will turn from crystalline to amorphous. So it is another example of efflorescence. Next term is deliquescence. Just the opposite of efflorescence. Deliquescence is a process of absorbing the water molecule from the atmosphere and getting dissolved in it. That means a substance, when it is absorbing water molecules on exposure to the atmosphere, from the atmosphere it is absorbing the water vapors, and then that substance particularly is getting dissolved in that water molecule, is called deliquescent salt. A very fine example is magnesium chloride. It can be liquid as well, and a solid example is magnesium chloride. Example can be calcium chloride. They can absorb the water molecule and dissolve in it. Now ferric chloride is also a very fine example for deliquescent substances. Ferric chloride absorbs moisture and dissolve in it very rapidly. So this question is asked that why ferric chloride is stored in airtight bottle. I think we had this discussion in class 8. Ferric chloride is deliquescent substance. It absorbs moisture from atmosphere, dissolves in it, sometimes becomes very much sticky. That's why always ferric chloride is stored in airtight bottle. Now the third term is hygroscopic. Hygroscopic is a term which is used, very similar to deliquescent substance, but there is a line of difference. The difference is that the dissolving factor. That means like deliquescence, hygroscopic substance also absorb moisture from atmosphere or from surrounding, but it does not dissolve in it. It remains dry. Now suppose we have example as P2O5, phosphorus pentoxide. It's a hygroscopic substance. It can absorb moisture, but it does not dissolve rapidly. So P2O5 can be one example. And another example can be anhydrous calcium chloride. Anhydrous calcium chloride is also used as absorbing water molecules, but without getting dissolved in it. Calcium concentrated sulfuric acid, we call also it hygroscopic, though it's a liquid. Concentrated H2SO4 also absorbs moisture from outside, and as it is highly soluble in water, so the amount of or the level of the bottle where the sulfuric acid kept is gradually increases. So from here another very important question comes that if we keep a sulfuric acid bottle, concentrated sulfuric acid bottle outside, it has to be concentrated, then you will find after 2 to 3 days the level increases slightly. What is the reason behind that? So concentrated sulfuric acid has a tendency to absorb moisture from the atmosphere. It's a highly hygroscopic, or it has a strong tendency or strong affinity towards the water molecules. So it will absorb the water molecules from the surrounding, and gradually the level will increase as the sulfuric acid will make solution with it. So now that is one give reason. Sodium hydroxide, which is a very strong base, is also highly soluble in water and it's strongly hygroscopic in nature. So on a watch glass, if you keep some pieces of sodium hydroxide, it will absorb moisture and will dissolve in it, which will become sticky due to absorption of water. And the process is highly exothermic as well. When it absorbs moisture, it starts dissolving it becomes very hot. And sometimes because of this reason, if you are using a glass vessel and you are not taking proper care, and while adding water, sometimes while making solution, there is a crack is observed in the glass vessels. So these are certain terms. So difference between hygroscopic and deliquescence is very important. Now if we talk about substances which are also known as desiccating agent, desiccating agents are those which are used in the desiccators. Desiccator is a glass apparatus where inside that glass apparatus we keep some deliquescent salts, that means which are very much sensitive towards the moisture, like ferric chloride. As you know, on exposure it may dissolve in it. So after preparing ferric chloride in the lab is kept in desiccator, and we keep certain substances so that the entire environment inside the desiccator remains dry. Silica gel is one example. As we know, silica gel is used in silica gel pouches are there in the thermoflask, in the new water bottles, in electronic goods. Everywhere you will find a small packet of silica gel. Now this silica gel is very much good absorbent. They can absorb water molecules nicely and keeps that particular container dry. So this is also used as desiccating agent. Like anhydrous calcium chloride also used. Anhydrous calcium chloride bulbs are there which is attached to the substances which are on the bottle, which are deliquescents, which protect the water, which protect the air which is entering to the inside the jar to let it dry. The water that will enter through that bulb will be dry. So the substance which is deliquescence in the jar will remain dry. So these are certain terms. I guess we have almost done these things which are there in the syllabus. So next we will be discussing the distinguishing chemically that I gave last day. So I have the questions. The first one I gave carbon dioxide and sulfur dioxide. Carbon dioxide does not have any effect to acidified KMnO4 solutions, or you can write only dark pink KMnO4 solution, but sulfur dioxide can decolorize dark pink KMnO4 solution. Second is magnesium chloride and magnesium nitrate. So here cation is same, anion is different, chloride and nitrate. So the best way to distinguish is silver nitrate. You give silver nitrate. Magnesium chloride will have a cardioid precipitate, and magnesium nitrate we will see no change. Third is dilute HCl, dilute SO4, that one we did previous week. So hydrochloric acid and sulfuric acid you can distinguish by adding barium chloride. If you are adding barium chloride to hydrochloric acid, there will be no reaction, and if you add barium chloride to sulfuric acid, there will be white precipitate. Fourth is calcium carbonate and lead carbonate, both the carbonates, so it is best to heat. If we are heating calcium carbonate, we are getting a white deposit, and if you are heating lead carbonate, we are getting a yellow deposit. And the fifth one is zinc and copper. We have seen displacement reactions. We know zinc is above hydrogen in the activity series, but copper is not. So if you give any dilute acids, best to give dilute hydrochloric acid or dilute sulfuric acid. So with dilute hydrochloric acid and dilute sulfuric acid, anyone, suppose dilute HCl we have taken. So zinc will react with dilute HCl to form a colorless, odorless gas which burns with pop sound, whereas copper will not react. We will see no observation when we are adding copper to dilute hydrochloric acid. So these all about today's discussion. Next day we will be continuing with water. Keep revising this chapter as well as previous chapters. Take care and bye.